Okay, in this video we're going to be talking about expected value. And so let's go ahead and get started. The expected value is a collection of outcomes to determine the expected value of each player. So in other words, it's the probability of each outcome times its value. Okay? Now, this is one of those situations where we can't it's hard to explain, so we just need to go ahead and dive into a problem. So let's go ahead and do that. A math test is announced for Friday. A student who's going to start studying on Monday is expected to make a 90 on the test. A student who's going to start studying on Wednesday is expected to make an 80, and a student who's going to start studying 5 minutes before the test is expected to make a 50. So whenever we're dealing with expected value and we're given a word problem, which let me go ahead and warn you, we're going to be dealing with word problems, the first thing you need to do is you need to highlight all of the different outcomes or all the different choices that are mentioned in this particular question. So what we have here, if you read, that we have a situation where students can either start studying on Monday, they could start studying on Wednesday, or they could start studying 5 minutes before. Okay, so what we have is three outcomes. All right. So what I'm going to do is I'm going to go ahead and write my three outcomes off to the side here. So this M represents studying on Monday, this W represents studying on Wednesday, and this 5 represents studying 5 minutes before. Okay. Now, with every outcome, you're going to have the value as well as the probability of that outcome happening, like this. Now I wrote this off to the side, and I'm actually using my mouse to write, so it's going to be a little messier than normal. So with every outcome, which I'm drawing an arrow to, you have the value of that particular outcome as well as the probability that it's happening. And of course, I wrote it as a percentage. Okay, so basically there's going to be two numbers per every outcome. And so if we're dealing with 1, 2, 3 outcomes, we're going to be dealing with 6 numbers total. Okay, so basically what I'm going to do is I'm going to write two blanks right next to every outcome because I'm going to need to know what the value of that particular outcome is. And I'm going to put a little V here just to represent value for each outcome. And I'm going to write a little P that represents probability, which is right here. Okay. Now, the value of each outcome is not necessarily always going to be in numbers or dollars or it's sometimes the value is going to be in different represented in different ways. So in this case, if you read, the value of making or starting to study on Monday is a 90. So the value of studying on Monday will be a 90 because that's what you're going to make on the test. Now, if you read, the value of studying on Wednesday is 80, and then lastly, the value starting or cramming basically 5 minutes before is a 50. So the next thing we need to do is figure out what is the probability of students studying on Monday. Well, if we read, it says 50% of the class will start studying on Monday. So that is going to be my value, or my probability for studying on Monday. And then 30% will be on Wednesday. And lastly, 20% will be on cramming 5 minutes before. Now I'm going to highlight something that is actually very significant, and that is the 50, the 30%, and the 20%. In order to move forward, you have to make sure that all your percentages in the problem add to 100%. Okay, because you're dealing with 100% of the population, because 100% of the population falls within those three choices. Okay, now once you have the setup, pretty much everything else is pretty simple. And so what you're going to do is you are going to multiply each pair of numbers for each outcome. And then after you multiply, you're then going to add it to everything else. Okay, so what that says, so what I'm going to do is I'm going to multiply 90%, or I'm sorry, 90 times 50%, which gives me a 45. And then 80 times 30, let's see, is 24. And then lastly, 50 times 20 is 10. And so I'm going to take these three numbers after multiplying and then add them together. And I'm just going to write this over here because I ran out of room here. I believe the answer is 79. So as a teacher, the question was calculate the expected value of the expected average grade of the class, and it is 79. There you go. Next question. Okay, and I'm not going to read this to you. If you want to, pause it so you can read it, but I'm just going to go ahead and solve it. All right. Now, the two outcomes is if I get a correct answer or if I get an incorrect answer. Okay. Now, some of the things that kind of make me know that I'm only dealing with two answers is because they really only give me two values. So if they only give you two values, you know you're only going to have really two outcomes. So I'm going to say C for correct answer and I for incorrect answer. Now remember that each outcome has two numbers attached to it, which is going to be the value and the probability of it actually happening. So the value of the correct answer, the value of the incorrect answer, and the probability of the incorrect answer. All right, so moving on. Now, if I was to go back into my if I was going to go back into my problem here, it says that I would gain $10 for each correct answer. So that's going to be a $10. But I lose $6 for each incorrect answer. So I cannot write just 6 because if I just write a positive 6, it tells me I'm actually gaining 6 for each incorrect. So to represent losing, I have to do negative 6. Okay. Now the next thing we have to do is figure out the probability. Now this is where it gets a little tricky because you got to make sure you read it correctly. Each question has 3 possible answers. Okay. So basically it's like a multiple choice question. Out of the three multiple, and think of it if you're on a test, if you have three possible answers, how many of those answers are going to be correct? Well, it's 1 out of 3. So in this case, rather than doing percentages, I'm now doing fractions. So if the probability is 1 out of 3, the probability of getting it incorrect is 2 out of 3. Now, in this case, once again, check to make sure your probabilities add up to get to one whole, and it does. So what I'm going to do now is I'm going to multiply, and then add what I have. And so since I wrote this a little high, I'm going to bring this down. So 10 times a third, that would give me 3.33. Negative 6 times 2/3 is negative 4. So I'm going to take these two answers and add them together so I get negative 0.67. Okay. Now the question is, if you do not know the answer to one of the questions, is it to your advantage to guess the answer? Well, because of the fact that my expected value was negative, that means that the game is already set up against you. So that means every question basically has an average of you going to lose money if you get it wrong. So that means it is not to your advantage. So you need to make sure you make the best or answer the best way possible. All right. Now the last one I want to show you is a lottery. Okay, and this is something that you need to make sure you understand because of the fact that there's some things that you need to assume in this that is not necessarily written. So let's go ahead and read all of our possible things that we can win. All right, we have a $100 prize and we have a $50 prize. So you could win two prizes, and hopefully you've already read this. Okay, so hopefully you've already read this, so you already know what I'm talking about. So you have a $100 prize, which that's going to be one option, is winning the $100 prize, and then you have the $50 prize. All right. Now, the one thing you got to remember is with a lottery or a raffle of some sort, yes, you have the possibilities of winning items, but you also has to factor in the losers. What if you don't win anything? That's also an outcome as well. Now, once again, two numbers will go to each outcome, one being the probability, one being the value. Let's deal with the value first. Now you might be saying, okay, the value of the $100 prize is going to be $100. Well, yes, but you got to assume something, that is that you already purchased a ticket for $6. So you've already purchased the ticket for $6, so that means your $100 prize has actually gone down to 94 because you're already $6 invested. And then the $50 one will be 44. And let's say if you lose, you never won anything, it'd be -6. Now the probability of winning, this says first 1,000 guests. So that means it's going to be out of 1,000. So that means one ticket out of 1,000 will win the $100 prize. Now this is where students get screwed up. One ticket out of 1,000 will win the $50 prize. A lot of students are going to want to say 1 out of 999. You can't do that because out of 1,000 tickets, you're right, one will win the $100 prize and everybody else will be losers, which means 998 tickets will be losers. Now check to make sure all your probabilities add up to get to one whole, which they do. So multiply, multiply, multiply everything, and then add what you got to get your final answer. And so the final answer is, after we multiply, you get negative 585. And there you go. So basically what this means is you paid $6 to get into this lottery, or into this raffle that is, and when you factor in the items that you could possibly win versus how many people that are playing this game, when you pay $6, you're expected to lose $5.85. Now, of course, you could win, but remember, when everything is averaged together, the expected value is going to be negative $5.85. So let me know if you have any questions. I hope you enjoyed the video. Thank you.